بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Good afternoon, my dear students, and thank you for joining the second part of the second part of the lecture related to cloud storing and big data. So let's continue by explaining the concept of distributed file system, and in which, in particular, we will relate it to the Hadoop distributed file system. Hadoop distributed file system, known as the HDFS, شحموت ويلا لك عروسي والله غلبش يا عشتي بخيرها. عيط لك قدام خطره ورا وين تسه ها بتيتت صباح والله الحمد لله عشك. خلصت واحدة، نزلت واحدة. هاني لو كنت في الابلودينج. لاباسها. مازلت مطول قدر دوك الساعتين. بيني بين الربعة هكذاك. انا نديرهم دوكا باسكو الانترنت عندي في الدار سي جامي تحبس هذيك يروح لي تسجيل هذاك وكله. على الاقل التسجيلات هذوك تاع 5 دقائق هذوك نقدر نديرهم في الدار، بصح هذو لازم نكملهم هنا. هذه بقات لي واحدة دوكا ونخلص. بقات لي هذه اللي راح درت دوكا خلاص، بقاو لي 2 اخرين. دوك نزيد ندير واحدة، تبقى لي واحدة نديرها السنة الجاية. واش راهي وانيا؟ وليدي الصغير، وليدي صباح النص ما لقاش الكيسان مرة. حتى بالكيسان نقصوا. وجدت غدا. يا بيان هاي. يا باي باي. تهلا في بالسلامة، عايشك. ويلا للمعروسة. So HDFS, in fact, is an implementation of Google file system. It's installed on Hadoop cluster to manage the distributed storage of a large volume of data on the cluster nodes in a completely fault-tolerant manner. More precisely, it fulfills 2 main points. The first point is to ensure the storage of data of the order of terabytes. As you know, 1 terabyte is equal to 1000 gigabytes, and also for petabytes. And 1 petabyte is equal to 1 million gigabyte across a large number of machines, and supports larger file blocks than traditional file systems. The second point, that it stores data redundantly in order to make the cluster fault tolerant. So thanks of these two functions, in which HDFS ensures a high level of availability to the cluster and increases the performance of MapReduce processing, in which we will talk in details in the next slide. However, these advantages are obtained at the cost of many trade-offs made regarding its architecture. In fact, HDFS only supports file read, add, and delete operations. So file modifications, operations such update and random 6 or random access to data are not supported. Unlike a classic distributed file system, HDFS does not provide a cache mechanism. For example, the file system reference table or specific to each node. Indeed, file blocks are much too large to be loaded, and which is approximately about 64 megabytes by default. Now, let's explain the concept of MapReduce, which is one of the most important and essential components of Hadoop platform. MapReduce is a programming model or framework available in Hadoop environment that is used to access big data stored in the Hadoop file system. So MapReduce is in fact a core and integral part of the Hadoop environment. It facilitates concurrent processing by dividing petabytes of data into smaller volumes and processing them in parallel on Hadoop dedicated commodity servers. In short, MapReduce aggregates data from multiple servers and returns a consolidated result to the application. For example, a Hadoop cluster of 20,000 servers with 256 megabyte data blocks can process, in fact, about 5 terabytes of data. So with MapReduce, you can therefore reduce the processing time compared to sequential processing of such a large data set. Instead of sending the data to where the application or algorithms are, the algorithms are executed on the server where the data already resides, which speeds up processing. And data access and storage are done on disk. So inputs are typically stored as files containing structured, semi-structured, or unstructured data, and output is also stored in files. Well, MapReduce used to be only way to retrieve data stored in the Hadoop distributed file system, but that is no longer the case. Today, there are other systems such as Hive and Peak that allow you to retrieve data from the HDFS using SQL-like queries. And these jobs are typically run concurrently with jobs written using the MapReduce model to take advantage of MapReduce's unique benefits. Here we have an example explaining how MapReduce works. Suppose we have the following input containing a file with 3 lines. The first line contains 3 words: deer, beer, river. The second line contains also 3 words: car, car, and driver. And the last line with also 3 words, which are deer, car, and beer. So before proceeding to the mapping operation, it's important to make a splitting of the input, which means that divided the input file to a defined nodes. So the first node contains the first line. The second node contains the second line. And the third node contains the last line. So the main idea of doing mapping is to create what we call a tuple, including a K and its corresponding value. Here, for example, for the deer, it appears 1 time. So here we have to define the tuple as deer 1. The same thing for beer. Since it appears 1 time, which refers to the number of occurrence, here we must define this tuple as beer 1, river 1. And the same thing for the second node and the third node. Car 1, river 1. Here, deer 1, car 1, beer 1. Now, the next step is to shuffle the data after doing mapping, which means that we have to collect all the keywords with the same mean in a node. Here, for example, we have beer here 1 and beer here 1. Also for the car, we have car 1, and here car 1. For deer, we have deer 1 and deer 1. For the river, we have here river 1 and here river 1. This is the shuffling step. Now let's move to the reducing step, in which we will make a sum of the number of occurrences of each K. So here beer we have 2, car we have 3, deer we have 2, and driver we have 2, and the final result in which will be represented in an output file containing all the words and their corresponding number of occurrence. Beer 2, car 3, deer 2, river 2 in one find, which represents the final results. We have also here another example in how to detect the common friend, for example, in Facebook. Here we have the input. Person A have friends B, C, D. Person B have friends A, C, D. Person C have friends A and B, and person D have friends A and B. When doing maps, here we have AB. So the person A and B have friends B, C, D, and also N and B have friends A, C, D. The same thing for AC. AC here we have has friends B, C, D, and A, B, and so on. So when now reducing this data, if we not here, for example, for the couple AB, AB as first have friends BCD, and here has friends ACD. Which are the common friends from this one and this one? The common friends are C and D. The same thing for AC. AC here we have BCD, and we have AB. So the common friends are only B. For the AD is B, for the BC is A, and for the BD is A. Okay. Now, let's explain the main tool or the main components through Hadoop platform. In fact, the MapReduce component of Hadoop tools directs the order of batch applications. So this component is in charge of the parallel execution of batch applications. The Hadoop common component of Hadoop tools serves as a resource that is used by the other components of the framework. For the HDFS is already explained. And we have also Hadoop Ozone, which is a component that provides the technology that drives object store, while Hadoop Submarine is a component that drives machine learning. In fact, Hadoop Submarine and Hadoop Ozone are some of the newest technologies that are components of Hadoop. For the Hadoop YARN is in fact the framework for job scheduling and resource managing, in which we will explain this framework in detail in the next slide. Here we have the Hadoop ecosystem, including the different kind of databases in which we can make connection, both structured or semi-structured or unstructured databases, such for example Hive, Pig, HBase, MongoDB, Cassandra, and so on. We have also here some other components for coordination, for example Zookeeper, and monitoring processing such Embari, data collection such scope, and Flam, and the workflow used by OSI. We have also all the main components of managing and analyzing the big data through Hadoop, using MapReduce to process data, Yarn to cluster resource management, and the HDFS, which consists to Hadoop distributed file system. So more details can be found through the following link. Okay. Now, let's explain the main role of Yarn framework. Yarn, in fact, is responsible for resource management and application scheduling. What we mean by resource management. In fact, the resource manager is the master daemon of Yarn and is responsible for resource assignment and management among all the applications. Whenever the resource manager receives a processing request, it forwards it to the corresponding node manager and allocates resources for the completion of the request accordingly. This means that an scheduled reboot or an expected downtime of the resource manager can adversely impact resource allocation to applications. Similarly, if a scheduled reboot does not occur, so here resource manager performance may suffer, and this is in turn can cause applications to not run. So to avoid such situation, administrators must keep an eye out for problem conditions such as a sudden reboot of the resource manager or an inspected uptime of the resource manager. So this can be achieved using the Hadoop resource manager uptime test. In fact, this test continuously tracks and reports the uptime of the resource manager, thus revealing whether or not a scheduled reboot occurred. Likewise, the test also alerts administrators to unexpected reboots so they can quickly investigate and determine the reason for the same and eliminate it. This way, the test helps administrators ensuring a high uptime of the resource manager. This is what about resource manager. Now let's explain the second task, which is related to application scheduling. In Hadoop, we can receive multiple jobs from different clients to perform. So the MapReduce framework is used to perform multiple tasks in parallel in a typical Hadoop cluster to process large size data set at a fast rate. This MapReduce framework is responsible for scheduling and monitoring the tasks given by different clients in Hadoop cluster. But this method of scheduling jobs is used prior to Hadoop 2.0. Now, in Hadoop 2.0, we have Yarn, which means the yet another resource negotiator. In Yarn, we have separate daemons for performing job scheduling, monitoring, and resource management as application master, node manager, and resource manager, respectively. Here, resource manager is the master daemon responsible for tracking or providing the resources required by any application within the cluster, and node manager is the slave daemon which monitors and keeps track of the resources used by an application and sends the feedback to resource manager. As conclusion, schedulers and applications manager are two major components of resource manager. The scheduler in Yarn is totally dedicated to scheduling the jobs, and it cannot track the status of the application. On the basis of required resources, the scheduler performs, or we can say, schedule the jobs. So this is what about resource management and application scheduling. Now let's explain, or let's highlight, some well-known simulation tools such GridSim, CloudSim, and SimGrid. Inshallah, we will focus mainly on CloudSim, since CloudSim is the well-used and the well-known simulator tool used by different companies and users. Now, as first, let's define what is GridSim. GridSim simulator provides facilities for the modeling and simulation of resources and network connectivity with different capabilities, configurations, and domains. It supports primitives for application composition, information services for resource discovery, and interfaces for assigning application tasks to resources and managing their execution. These features can be used to simulate resource brokers or grid schedulers for evaluating performance of scheduling algorithms or heuristics. This is what about GridSim. For the SimGrid is a scientific instrument to study the behavior of large-scale distributed systems such as grids, clouds, HPC, or P2P systems. It can be used to evaluate heuristics, prototype application, or even assess legacy NPI applications. Now let's explain CloudSim. CloudSim is an open source framework which is used to simulate cloud computing infrastructure and services. It's developed by the Clouds Lab organization and is written entirely in Java. It is used also for modeling and simulating a cloud computing environment as a means for evaluating a hypothesis prior to software development in order to reproduce tests and results. For example, if you were to deploy an application for a website on the cloud and wanted to test the services and know that your product can handle and also turn its performance to overcome bottlenecks before risking deployment, then such evaluation could be performed by simply coding a simulation of that environment with the help of various flexible and scalable classes provided by the CloudSim package, which is free of cost. In fact, the last version of CloudSim is 5.0, using integrated development known as the IDE, based on Eclipse Classic or NetBeans. And also, it can add external jar common math functions. In fact, the folder structure in CloudSim can contain some useful subfolders, such for docs, which is docs. This is for the CloudSim documentation. Here we have the folder of examples by providing some CloudSim examples. For the jars is for the CloudSim jar archives, and sources for the Cloud SIEM source code. Okay. In fact, the architecture of Cloud SIEM is based on 3 layers: the Cloud SIEM core simulation engine, the Cloud SIEM itself, and the user code. For the user code, including cloud scenario, user requirements, application configuration, and user data center broker. For the Cloud SIEM, it includes user interface structured virtual machine services, including cloudlet, virtual machine, and virtual machine management. For the cloud service, it represents the virtual machine provisioning, the central processing unit allocation, memory allocation, bandwidth allocation, and storage allocation. For the cloud resources, it includes the events handling, sensors, cloud coordinator, and data center. And finally, for the network, which refers to network topology and message delay calculation. So this is mainly the Cloud SIEM architecture. Now, Cloud SIEM is mainly based on some essential components, and which can be summarized as the data center, the host, the data center broker, the virtual machine, the virtual machine allocation policy, the virtual machine scheduler, the cloudlet scheduler, the cloudlet information service, and so on. In fact, the Cloud SIEM core simulation engine provides interfaces for the management of resources such a virtual machine, a memory, a bandwidth of virtualization data centers. Cloud SIEM layer manage the creation and execution of core entities such as virtual machines, cloudlets, hosts, etc. It also handles network related execution along with the provisioning of resources and their execution and management. For the user code, as explained here, is the layer controlled by the user. So the developer here can write the requirements of the hardware specifications in this layer according to the scenario. Some of the most common classes used during simulation, for example, data center, the host, the virtual machine, the cloudlet, the data center broker, and Cloud SIEM. What we mean by the data center? Data center is used for modeling the foundational hardware equipment of any cloud environment. That is the the data center. This class provides methods to specify the functional requirements of the data centers, as well as methods to set the allocation policies of the virtual machines, etc. For the host, this class executes actions related to management of virtual machines. It also defines policies for provisioning memory and bandwidth to the virtual machines, as well as allocating CPU cores to the virtual machines. For the virtual machine, this class represents a virtual machine by providing data members defining a virtual machine's bandwidth, RAM, MIPS with million instructions per second, size, while also providing setter and gather methods for these parameters. For the cloudlet, a cloudlet class represents any task that is run on a virtual machine, like processing tasks or a memory access tasks or a file updating task, and so on. In fact, Cloudlet stores parameters defining the characteristics of a task such as its length, size, and provides methods similarly to virtual machine class, while also providing methods that defines a task execution time, status, cost, and history. For the data center broker, data center broker is an entity acting on behalf of the user. It is responsible for functioning of virtual machines, including virtual machine creation, management, destruction, and submission of cloudlets to the virtual machine. For the Cloud SIEM, this is a class responsible for initializing and starting the simulation environment after all the necessary cloud entities have been defined, and later stopping after all the entities have been destroyed. As you can see here through this figure, virtual machines allocation policy objective. So the objective is of this policy is to use the resource by making all processing element for particular host base. Okay. Now let's explain the main policies related to virtual machine allocation, virtual machine scheduler policy, and cloud scheduler policy. The Cloud SIEM simulation toolkit framework has effectively addressed the scheduling scenario and implemented it as a set of the programmable class hierarchies with parent class as virtual machine scheduler, cloud scheduler, and cloud dev scheduler policy. Also, virtual machine and task, which is related to cloud dev scheduling, are one of the most important and the popular use case to be simulated by researchers using the Cloud SIEM simulation toolkit. And for the virtual machine scheduler, in fact, is an abstract class that defines and implements the policy used to share processing power among virtual machines running on a specified host. So the hierarchy of the Cloud SIEM virtual machine scheduler classes can be summarized in three main tasks: the virtual machine scheduler time shared, the virtual machine scheduler space shared, and the virtual machine scheduler time shared over subscription. What we mean by the virtual machine scheduler time shared? This class implements the virtual machine scheduling policy that allocates one or more processing elements to a single virtual machine and allows the sharing of processing elements by multiple virtual machines with a specified time slice. For the virtual machine scheduler space shared, this class in fact implements the virtual machine scheduling policy that allocates one or more processing elements to a single virtual machine, but this policy implementation does not support sharing of processing elements. So here, all the requested resources will be used by the allocated virtual machine till the time the virtual machine is not destroyed. And finally, for the virtual machine scheduler time shared over subscription, in fact, this is an extended implementation of virtual machine scheduler time shared policy, which allows over subscription of processing elements by the virtual machines. So the scheduler still allows the allocation of virtual machines that require more CPU capacity that is available. And this oversubscription results in performance degradation. For the cloud set scheduler policy, in fact, the cloud set scheduler is an abstract class that defines the basic skeleton to implement the policy to be used for clouded scheduling to be performed by a virtual machine. So the hierarchy of the cloud SIEM, cloud set scheduler class is as cloud set scheduler space shared, cloud set scheduler time shared, and cloud set dynamic work load. For the cloud set scheduler space shared, this is class, or this class implements a policy of scheduling for virtual machine to execute cloudlet or cloudlets in space shared environment. So only one cloudlet will be executed on a virtual machine at a time. For the cloudlet scheduler time shared, this class implements a policy of cloud scheduling for virtual machines to execute cloudlets in a time shared environment. So here, more than one cloudlet will be submitted to the virtual machine, and each will get each specified share of time. It means several requests, which refers to cloud sets, are processed at once, but they must share the computing power of that virtual machine by simulating context switching. For the cloud set scheduler dynamic workload, this in fact implements a special policy of scheduling for virtual machine, assuming that there is just one cloudlet which is working as an online service with a different requirement of workload as per the need of peak user load at a specified period of time. Here we can cite some algorithms used in CloudSIEM. We have, for example, the first come first serve algorithm, round robin algorithm, mean and max mean, mostly task scheduling, priority scheduling algorithm, genetic algorithm, particle swarm optimization, resource aware scheduling, dynamic performance, and so on. So this is the main algorithms and approach used in CloudSIEM. We have here also some tools and plugins used in CloudSIEM, such Cloud Analyst, Green Cloud, Icon Cloud, MDC SIEM, Network Cloud SIEM, Cloud MIG Express, Virtual Cloud, Cloud Reports, Cloud Auction, Dynamic Cloud SIEM, Real Cloud SIEM, and Workflow Cloud SIEM. So here, since we are limited by time, unfortunately, I cannot explain all of them, but if you wanted to get more information about the used algorithms and techniques, and also the main tools and plugins used in CloudSIEM, you can find them in internet or in web, sorry. Now, let's focus on the research carried out through CloudSIEM, and which can be summarized in 7 main points: the load balancing, data centers, resource provisioning, creation and also execution of cloudlets, task scheduling, cost and storage factors, and finally, energy optimization. What we mean by load balancing. The basic idea behind this algorithm is to check if there are any free hosts in the data center, and if there are any, then it assigns a process to that host and decreases the numbers of free processors with that host. So if there are no free hosts but have some free processors, then it checks the host with the maximum number of processors and assigns the new incoming process to that host. For the data center is to simulate cloud infrastructure in CloudSIEM. So you need to understand the essential components involved. Data centers are the core of cloud infrastructure. So in CloudSIEM, a data center represents the physical machines called hosts that provide computing resources such CPU, memory, storage, and bandwidth. Now, what we mean by resource provisioning. In cloud computing, resource provisioning is the process of allocating physical or virtual resources like servers, CPU, memory, and storage to virtual machines or applications based on demand. In CloudSIEM, resource provisioning is simulated through the allocation of resources from hosts to virtual machines and the scheduling of tasks known as cloud sets to virtual machines. CloudSIEM simulation toolkit allows researchers and users to simulate and experiment with different provisioning strategies and policies by enabling them to explore how resources can be efficiently managed in real-world cloud environment. So here the simulation means that you define your real-world runtime requirements programmatically. Then the CloudSIEM simulation engine will follow the similar workflow of cloud computing system and produce the performance results using mathematical models which are closest to the real-life cloud systems workloads. Now let's talk about the creation and also execution of Cloudlet. Cloudlet in CloudSIEM defined the workload, which is to be executing during the simulation run of the CloudSIEM simulation engine. Cloudlet in CloudSIEM is a model class that exists inside the package arc.cloudbus.cloudsiem. In fact, a cloudlet is one of the most important models which defined the specification for simulation engine corresponding to the real-life candidate application to be considered for moving to a cloud-based system. In contrast, we can also define this cloudlet as a single process or task being executed on cloud-based system, which is to be simulated through a cloud sim simulation engine. So the cloud let model class defines also 4 or 5 constructors for initialization. Now let's explain the task scheduling through Cloud SIEM. Cloud SIEM task scheduling refers to the process of assigning tasks, also called the cloudlets, to virtual machines in a cloud environment. So efficient Cloud SIEM task scheduling is crucial for maximizing resource using, reducing execution time, and optimizing overall cloud performance based on the analysis of simulation results. In Cloud SIEM, task scheduling involves deciding which cloudlets should be executed on which virtual machines. By taking into account the resources available in each virtual machine and the characteristics of each task. So the main goal here is to ensure the goal, or to ensure that tasks are completed efficiently while balancing the load across available resources. And the learning from the simulation are used to improve the real-world cloud systems. We have here also some research carried out related to costs by minimizing costs and optimizing energy. So this is what we have. Also here we have some main issues related to Cloud SIEM. For example, security and integrity, virtualization in cloud, privacy provisioning in multi-tenancy cloud, the data segregation and also recovery issue, securing cloud architecture, resource optimization scheduling, and cloud cryptography, and also the verifiable computation. We have also the trusted computing technology and secure computation outsourcing, work with failure detection and prediction, securing management of virtualized resources and securing mobile cloud, key management and cloud access control, data segregation and software security, security in data centers for data management, privacy aware in protocol design. So this is what we have mainly in the second part of chapter 6. Thank you for your listening, and assalamu alaikum wa rahmatullahi wa barakatuh.